Well, the string will be taut, and how the tension will act. Tension will act. It's all about the showing the various forces that are acting. So where the weight of the rod will act. So I'll begin with the question. So the weight of the rod. For each rod, you can show the weight will act vertically down. There's a normal contact, and here there's a ring is there, and the three rods they are binded here at point 2. There'll be some force. We don't know how that force will be acting. After getting N and Mg, we can start thinking on it. And here the string will be taut. This will be tension. So under action of all these forces, what happens? The rod is in equilibrium. So this ring will exert horizontal force only. So therefore N should be equal to Mg. You look at any rod. Either you look at any rod, this rod. So therefore what is the normal reaction? N minus Mg equal to 0. This rod. Okay, let's come for the equilibrium. Let's get into the triangle. Triangle ACB. This is a triangle ACB, and let this be the let me define that point P. What can be length? All strings are of equal length. Three identical strings, each of length L by 3. So length of the strings is how much? L by 3, L by 3, and L by 3. So therefore it should be equilateral triangle. So 30 degrees, 30 degrees. Then one more. Let me draw a line. So what can be other angle? So how the tension here, it will act in this way. Just it's all about the geometry here. So this angle will be 60 degrees, 60 degrees. So from O, if I look at no, I'll get an equilateral triangle, and that is what this ACB. I'm just showing tensions on this one. And there's a point P. What can be point P? What can be that point P? Will it lie exactly below O? Yes, it must be no. It's an equilateral triangle. The point P will exactly lie below O. So let me go for one more triangle. This is O, this is P, and this is A. So this length is how much here? So look at this one. Between AB and BC at a distance 2L from the topmost point O. So what can be distance OE? 2L by 3. What is the distance AP from equilateral triangle? What can be distance AP? Anybody? Anybody value? L by 3. Oh, okay, fine. So we can calculate the distance OP also, which we are going to take help in the problem. So let me take that as H. So this angle, let me define theta. Where is the theta? The theta will come here. So that OP is what? Imaginary line. The P will lie exactly below. So somewhere you write it. P lies. One equation we have generated O. So let's look at the any one rod. So I'm going to take the rod OA, that one. So what should be the total forces acting on it? Due to all the forces that are acting, the net torque should be zero. There'll be some forces acting at O because the three rods are joined. No, there'll be some forces acting that one. So therefore, about which point shall I define torque? Shall I go for about O, about A, about D, or about the center of mass of the rod? Which point I should be? Because I don't know the nature of force about O at O. No, some horizontal force will be acting. So because of that, what happened? I'm unable to judge. Like, so can you can ask questions, sir? Can you say what can be the direction? I think you see N will act vertically up, mg will act vertically down, mg will act vertically down. Component of tension will act horizontal, or say somewhere like this. So definitely there should be some force acting in this direction. That I'll show it here. This will call some reaction force. Now about point D, if I apply torque, mg, the tension I don't know. Rx also I don't know. So therefore, what is the best thing? Let me define the torque about O. So that mg we know, mass of the rod, and the tension is what I'll calculate, the unknown thing. So let's define the torque about O, that one. And it's in equilibrium, no? Torque about O for any one rod. So here, what is the rod? I have information on the rod OOD. On the rod OD will write it. Let's go for the torque. How to write the torque equation? mgl sine theta, mgl by 2 sine theta. This torque will be anti-clockwise, about 0.2. I don't have any other equation, so this I should not write this is theta. All of you, I should not show this is theta. Getting? Theta should be here only. Theta is not angle between the rods. Theta is angle between the rod OD and the vertical OP. So the torque by the weight about O, clockwise or anti-clockwise? Should be anti-clockwise. Then torque due to tension. So look at this diagram, the triangle here. So torque due to tension. 2t cos 30 will act here, will pass through point P. So along AP, shall we show 2t cos 30 into that distance h? So this will be 2t cos 30 into h, perpendicular distance. Now what should be the sense of this? This should also be anti-clockwise, no? And then torque due to normal contact. There should be N, L, sine theta clockwise. N is equal to mg, substitute that, the equation 2. Then solve for t. So we need h. I think you can, we got a right angle triangle. So from there, 2l by 3 whole square equal to l by 3 whole square plus h square. Solve the value of h, substitute, you'll get the required answer. Okay, just make observation. I'll scroll down. On any one rod, because the system is in equilibrium, come for this. Already we are done with the triangular plate, So with square plate with hemisphere. Now there's a rod, very popular problem. This rod is in equilibrium. The rod of mass and length is in equilibrium. Both the walls, vertical and horizontal wall, is rough.